Okay, so this is chapter 1, and I'm going to go about halfway through the chapter tonight since it is a review. So I'm going to cover all the matter stuff tonight, and then in the next lesson I will cover all the measurement stuff. So let's get started. What is matter and how is it classified? How do we define matter? Well, you can take your own Reader's Digest notes. You don't have to write exactly what I do. It's just so long as you know what it is, if it's on a test, quiz, or problem. So, anything that has mass and takes up space. And what are the states of matter? You should know these off the top of your head. And what are their identifying characteristics? So we had solids, liquids, and gases. So here we know definite shape and volume. Again, if you know this, you don't have to write it. I'm doing it for the benefit of those that haven't had chem in a while. Liquid, distinct volume, which is independent of its container. And gases, of course. No definite volume or shape. Remember that gases are also called a vapor. My pen is a little off tonight. So gases uniformly fill their container because they spread out as far as they can. And here we have the 3 states. Remember, gases, a lot of entropy, okay? Much empty space, particles have complete freedom of motion. In a liquid, there is some disorder, not as much entropy as in a gas. Particles are closer together, but there is some space so that they can roll past one another. And in a solid, it's an ordered, patterned arrangement. It's usually referred to a geometric pattern, crystalline solid, fixed proportions. What is matter and how is it classified? Matter can be classified in terms of its composition. So the most general way we classify matter is into 2 groups, pure substances and mixtures. So just so you know, pure substances are usually just referred to as substances. So if we see the word substances, then we're assuming that it is pure. And what that means is the composition does not vary. Between samples. And we have elements, which you know cannot be broken down. I'm not going to write that. If you want to write it, that's fine. And we have compounds, which are 2 or more different elements chemically combined. and they can be broken down by chemical means into their constituent parts. The law of definite composition, also known as Prowse Law or the law of constant composition. We've never heard it referred to as Prowse Law. This is more in the chemistry history books. Proust was a French chemist around the 1800, and he actually came up with this law. And it's also called, we referred to it this last year as the law of definite proportions. So basically, all of these are synonymous. And what it says is pure compounds have the same composition and properties under the same conditions, regardless of its source. So if you have two samples and they differ, then it's either because they differ in purity or they're just a different compound. If you recall, most of you should remember that took chemistry last year, the composition of a hydrate lab, in which you were to determine the amount of water molecules in the hydrated crystal. So whether we use copper sulfate pentahydrate or barium chloride dihydrate, okay, the proportion of compound to water molecules is going to be the same unless we don't have a pure sample or we change it and it's a different compound. So you might have copper sulfate pentahydrate or copper sulfate trihydrate. If you change the water molecules in the compound, then it's two different compounds. So let's talk about mixtures. So we know what substances are. Pure substances are either elements or compounds. Elements can't be broken down. Compounds can. Now we move on to mixtures. We have two different types of mixtures. They're either homogeneous or heterogeneous. And heterogeneous means that they vary throughout. And homogeneous is uniform throughout. Most of the substances that we encounter in the real world are mixtures. And what's really important about each mixture is that each substance in the mixture retains its original physical properties. I'm not going to write that. If you need to write it, please feel free to do so. Each substance in the mixture retains its own physical properties. And one thing that we want to remember is that all solutions are homogeneous. If I dissolve salt in water, it's evenly distributed, the salt molecules throughout the water molecules. Same with sugar, or when I make a solution to use in a lab. There are so many different identifying characteristics of matter. These properties of matter dictate how substances will behave in a chemical reaction. So we have two types of properties. We have physical properties, properties that can be observed without changing the identity of the substance.
Oh my goodness, Katie, you're barking at me? You're on your home?
Some examples here are color, density, melting point, boiling point, odor, hardness. Okay, chemical describes the way a substance may change or react. A good one of this is flammability. Another one would be reaction with acids. All right, moving right along, we're almost done. Less commonly talked about are the intensive and extensive properties. Usually at the college level, you have to know the difference between the two. An intensive property doesn't depend on the amount of the substance. And an extensive property does depend on the amount of the substance. For example, mass and volume. So your mass and your volume are going to change depending on the amount of substance you have. The temperature, the melting point of a substance, is not going to change regardless of how much you have. That would be intensive. And finally, the rest of the year we will study how matter changes and energy associated with those changes. So matter can change in two ways: physical, so change in appearance or change in state, we can say, not its composition. Wow, my pen is not cooperating. And chemical. Substance is transformed into a chemically different substance. We take advantage of these properties of matter when we try to isolate particular compounds out of a mixture. So a mixture, remember, its constituents retain its own physical properties. Therefore, we can separate them into their discrete substances. One way that we do that is distillation, which should be very familiar. Separation by boiling point. Here's an example of fractional distillation. And you had a lab or a picture of this similar last year. Notice that when you have 1 to 4 carbons, the boiling point is extremely low as opposed to 100 to 300 carbons. And this is different types of fuel. You can see fuel that you put in your car, octane, usually about 8 carbons, has a boiling point of anywhere from 40 degrees to 200 degrees. So the more carbons, the stronger the bonds, the higher the melting and boiling point. A little bit of review there. A couple of other ways that we can separate: filtration. I am not defining these. So if I have sand, water, and salt, I can evaporate, or actually I can filtrate the salt water from the sand, because the sand will get trapped in the filter paper, and then I can evaporate the water and be left with the salt. And another one is chromatography, which I believe we actually do a college level chromatography lab. And that's when you have a mobile and stationary phase. And your stationary phase is usually your solid, and your mobile phase is either a liquid or gas. Because there is gas chromatography, which you'll do in college, and then liquid chromatography, what we do. This is just showing you the difference between a mixture and if you have a filter and the filtrate. The residue are the particles that are too large to pass through the filter, and the filtrate is the liquid substance that's small enough to pass through. So you don't have this in your notes. I'm just going to review what we've been talking about. So we have matter at the top, and then we ask ourselves, is it uniform throughout when I'm looking at something? So that's the question that I say to myself. Is it uniform throughout? If the answer is yes, then it is homogeneous. Wow. The answer is no, then it is heterogeneous. If it's homogeneous, this is a heterogeneous mixture over here. If it is homogeneous, then I'm going to, because remember, matter itself can be an element or compound. So when we say, is it homogeneous, we're going to next ask, does it have a variable composition? I'm going to abbreviate the word composition. If the answer is no, then it is a pure substance. And then we're going to ask ourselves, does it have more than one type of atom? I don't know what is the matter with my pen tonight. I really apologize. It's being difficult. One type of atom. If the answer is yes, then it is a compound. And if the answer is no, then it is an element. And over here, if the answer is yes, then it is a homogeneous solution.